The world of automation is undergoing a paradigm shift. This changes everything. Welcome to Universal Automation. The world of plug-and-produce software components, making complex things simple and reliable. Think of it as the dawn of an industrial automation app store. The IEC 61499 standard is the key to portability and interoperability. UniversalAutomation.org is the community managing an industrial-grade reference implementation of 61499. Because no one vendor or company or person can bring about transformation on their own. Universal Automation allows us to use software and hardware in a whole new way to create portable applications and innovative architectures. For the first time, IT and OT engineers can easily work together, combining real-time with right-time to create cost-effective and innovative ways to address complex use cases, like predictive maintenance, production optimization, and virtual commissioning. But how does Universal Automation really impact you? Vendors can use the Universal Automation reference implementation to bring IEC 61499 offers to market fast. That means new software revenues, new business models, and new customers. Universal Automation frees industrial enterprises to integrate best-of-breed components and proven in-use software. You can realize step-change advancements in efficiency, flexibility, and modularity with agile operational models. It's time for us to release the full potential of the fourth industrial revolution. Be a part of the community delivering the solution. Join universalautomation.org.
Hi, everyone. Good morning, good afternoon to you from all over the world. My name is Greg Book. I'm the Chief Marketing Officer of UniversalAutomation.org, and I'm happy to host today the new session of UAO Goes Live. It's been a while since we have discussed, and today we have a very interesting topic on the stage. The topic of AI is in all mouths. Some people tend to think, okay, AI will replace everything within the workforce. Some others tending to use AI as actually a way to, let's say, make the automation revolution coming even faster and AI replacing all automation languages. On the other hand, we have UniversalAutomation.org based on the IEC 61499 standard, which offers a framework, because IEC 61499 standard is not a programming language. It offers a framework which could be used to multiple programming languages, but as well to AI. Why not? So the topic of today, it's already the third part that we are talking about AI integration into the IEC 61499 standard and UAO technology. So I'm happy to welcome today on the stage Professor Valeriy Vyatkin, Dmitrii Drozdov from Flexbridge, and Tatiana Liakh from the Luleå Technology University. So hi to you all. For this session, please feel free to ask your questions. Ask your question on the chat. Ask your questions directly on LinkedIn, on YouTube, and we will take them to answer at the end. Okay. So hi Valeriy, hi Dmitrii, hi Tatiana. Let's start with a short introduction. I will start first with the introduction of Dmitrii. If you can spend 1 minute to introduce yourself. Then we go to Tatiana, and we end with Valeriy. Dmitrii?
Okay, hello, Greg. Hello, everyone. Thank you for inviting me today. I am a Chief Technology Officer from Flexbridge. We're a small company in the north of Sweden, stemmed from the university research, and now we're trying to push forward truly decentralized control systems.
Thank you, Dmitrii. Tanya, do you want to introduce yourself?
Yes, hello everyone. Thank you for the invitation, Greg. My name is Tatiana Liakh. I'm from Luleå Technical University. It's not close to Flexbridge, also very, very north. So yeah, if you will go to this university, and at correct time, at correct place, you can see the northern lights. Yeah. So my research interest is also decentralized industrial automation, AI agents for this decentralized industrial automation, different verification techniques, and how to make AI in automation real trustworthy. Thank you very much.
Thank you, Tanya. Valeriy?
Yes, hello. My name is Valeriy Vyatkin. I'm professor at Luleå University of Technology, also at Aalto University. And today I'm going to speak about ongoing European research project, about the techniques that we are developing within this project, which are, as Greg announced, AI-based services for flexible automation.
Great. Thank you, Valeriy, for this this short introduction. Let's jump into the topic, and let's start with your presentation.
Okay. Yes. Again, very good afternoon, everybody who joined this stream. I'm going to speak about AI services for flexible automation, and in particular, these recent results we achieved within a European project called Medusa. The project started in the end of 2024, and now we are in the middle of the project, but we already have quite interesting results. And I want first to put you a little bit in context, because this Medusa project is dedicated to manufacturing as a service framework, exploiting decentralized secure data exchange, promoting sustainability and circularity. So the key words here is manufacturing as a service. I want you to imagine like a scenario that is easy to digest of manufacturing as a service. Suppose that you want to order a car that would have some kind of customized painting like the one on the screen with Marimekko flowers on the car paint. And you go to some web platform where you present your dream. And this Medusa platform, that is a target of Medusa project, will be trying to fulfill your dream by contacting the available manufacturers who advertise such services. And it could go deep enough into the internal data of these manufacturers to understand to what extent they are capable of fulfilling this task of how precise they can make the paint on your car, and how available they are, when and at what cost they will be able to deliver the result. And all these offers from the manufacturers will be passed to the platform for matchmaking and for deciding which one will be winning and kind of granting the order from the customer. And doing that may require quite deep plunge into automation system of each manufacturing site, understanding what are the skills and what are capabilities and abilities of each of these manufacturing sites. So if we look into industrial automation side of Medusa, which is not the whole project, of course, the project is much bigger and is covering everything in this big picture, but the automation side of Medusa, we can see the following workflow. The automation developer who would need to implement possible requirements that are coming from the customer's customized product implementation. So all these requirements may include original design documents, capabilities of equipment, wiring diagrams, description of the product, etc. So all this information will be digested by the automation developer, and using software tools such as an integrated development environment, it will be translated into executable code using IEC 61499 language or architecture, in which the idea will be implemented. Then using the tool, it will be materialized into executable code, downloaded into runtime. And in Medusa, we agreed that we will use a specific design pattern for development of modular and flexible automation systems that is based on the concept of skills. So what are the skills? I just want to quickly remind you that skills is not our invention. We refer to documents created by such respected organizations as VDMA and OPC UA, who have created this concept and even implemented it using OPC UA demonstrator, as you can see in this video in the slide. That was used as a kind of concept proof for the skills idea. So this assembly machine, where more than 30 different vendors combined their force to demonstrate that skills as an architecture could help achieving interoperability between different vendors. So design of automation system from independent modules coming from different vendors, and then exchanging messages that are high-level commands, which are the skills. So these basically are high-level commands which allow one, let's say, part of the machine call operation in another part of the machine in a very easy way. So for this particular machine, you can see illustration how the whole process was decomposed and organized on the skills of entire cell level, then of subcomponents, then of smaller components, and so on and so forth, down to the operations of such basic components as pneumatic cylinders and motors and other basic mechatronic devices that build this system. So the skills is a quite established concept in automation. It's supported by standards, and in a recent European project, Zero Swarm, it was linked with also with IEC 61499, where we demonstrated how the concept of skills, which has multiple sites, so these basic operations can be invoked through OPC UA, but they can be also implemented as function blocks of IEC 61499 and invoked by just invoking, emitting events to the function blocks. So they have this kind of duality, and simultaneously it can be reached out through different communication means. And if we look into internal organization of a skill in IEC 61499, it can be represented as a composite block or CAD in EcoStructure automation tool, where it has a well-defined internal structure. And one core part of that skill is so-called skill basic function block, which has external interface. So the third way how the user can communicate with the skills is through HMI panel, through some kind of faceplate where the user can just press buttons. And also it has a standard state machine that defines operation of any skill. So any skill doing any type of operation follows on the top level this state machine, which is kind of very good way to make to document and explain the user how every skill operates. But there is also a specific control logic of the skill that is defined again as a state machine and implemented as another logic function block that is a part of this composite skill function block. So when we design automation of modular systems, such as this packaging line of our project partner Repack, what we ideally want to do is we want to fetch skills from the library of skills, one like top level skill per one module, and organize our software in a way that is very similar to mechatronic organization of our production line. So that is the dream of automation engineer, right? Just fetch, connect, plug and play. So, but in the context of our Medusa project, when we have different production lines advertising their services for fulfilling a particular request from Medusa platform, we may come into the situation, may encounter the case when certain production line only partially fulfills the requirements. And Medusa platform needs to understand to what extent this production line fits to fulfilling the requirements and maybe identify gaps, what is missing, and try to suggest what can be added to this production line in order to make production of certain product possible. So Medusa platform would first interrogate, even like online, connect to production line, understand its internal organization, understand its software skills, and then make suggestion. Having received product and process requirements from the customer, it may suggest that certain mechatronic units need to be added to this production line and certain software skills need to be developed and added to make the whole production line capable of fulfilling the overall task of the customer. And this is where we are. And this is the problem what we are trying to solve. How to automate this process, how to make it like zero effort for the developer using artificial intelligence. So the workflow we are working on in Medusa project is as follows. So we receive Medusa web platform receives orders from the customer, and here we have fbAssistant tool that will be helping automation developer to create the software artifacts, having received the requirements, original design documents, and product descriptions. It will, instead of automation developer manually developing software, it will just generate automatically the needed software and let automation developer to understand what is suggested and refine it in order to make it fully correct and running. So we already, in the previous sessions of LinkedIn Live, we already presented the basic idea of a function block assistant tool that runs in parallel with IDEs for IEC 61499, such as EcoStructure Automation Expert of Schneider Electric or with any other IDE. And it can, receiving natural language requirements, it generates equivalent state machines which implement these natural language requirements. Then it can generate function blocks of IEC 61499, put it in the repository that is immediately can be picked up from EcoStructure Automation Expert, for example, and executed, compiled, and deployed to PLCs. Also, Function Block Assistant has a service feature of directly simulating state machines against simulation models that are deployed and run from EcoStructure Automation Expert. So this is just a reminder to you, if you missed the previous sessions, the basics of Function Block Assistant tool. And also within this Medusa project, we are exploring the potential of ontological knowledge representation that helps us to have a unified representation model of different types of knowledge. Of the knowledge that describes production lines, knowledge that describes the product, and the knowledge that describes our automation software. These are quite different artifacts, and it's quite hard to describe them with the same means. That's why we are using these ontological representations, using semantic web technologies, where all of this can be represented within the same knowledge framework. So let me illustrate what I mean by using a smaller example of mechatronic system that we will use as a running case in the demonstration today. So this is a combination of two small machines from Festo Didactic. One is a magazine for storing work pieces, and the other is a pick-and-place manipulator that's taking a work piece from this magazine device and placing it to the other side just to continue processing in other machines. So if you look deeper into this machine, it's composed of like two mechatronic components, and each of the mechatronic components again is composed of several elements, such as the magazine and the pusher. The magazine itself has like a tube with work pieces and sensor, and then other components also have some kind of complicated internal organization, including sensors, including suction unit here, and so on and so forth. So when we apply the skills concept, of course, on the top level, there should be like a skill that is describing operation of the entire system. But each mechatronic component will come with its own skills, which need to be combined and orchestrated into the skill of the entire system, and that applies downwards to all the levels of hierarchy. So when we're looking at the distributing station physical organization, and we use this knowledge graph as a graphical representation of semantic web view on that, we can see that distributing station has like two parts, transfer unit and feeder unit. Then transfer unit is composed of transfer arm and vacuum unit, and so on and so forth. So this graphical way has also equivalent textual way of presenting this knowledge using web ontology language. But for simplicity, we will use just graphical in this presentation so that it's more understandable what we mean by ontology. The same applies to description of production process. We can also represent it graphically using the same web ontology language or knowledge graph, and we can apply the same idea to describing our software. So, like if we imagine that for this mechatronic system, we would need three software skills, three software components to operate it. One for like pushing workpiece forward. Another is for filling and replenishing the magazine with more workpieces, and the third for pick and place operations. So we would have 3 skills, 3 software components. Then using ontological representation, it would look like this semantic graph. So we have 2 atomic skills, one for loading workpieces, another for pushing workpiece out of the magazine with its organization. And then we will have composite skill where this operation of a pick and place unit is decomposed into 4 atomic operations. One is like going to the right, move arm right, another move arm left, switching vacuum on and sucking workpiece in, and then dropping workpiece out. So this semantic graph represents operation represents the overall software structure of this system. Now we can combine all of these together because they use description, they use the same ontology, web ontology language, and we can start reasoning on top of it to understand whether the combination of software capabilities and mechanical capabilities and maybe electric capabilities is good enough to manufacture the product described in the same language. And we can use for that the reasoning methods, which are supported by tools for ontology, but also we can use power of LLMs, which can be fed with all these inputs and which can try to guess what is missing here or whether this is sufficient for manufacturing. Okay, so what is our basically vision and ambition? We want to drastically simplify the path from all these requirements written in natural language and other requirements describing the product and describing the process, looking like original drawings, maybe technical drawings, PDF files. So take all these inputs and with a sort of one button click, convert it into fully executable IEC 61499 software that can be deployed and control real automation systems. So for that, Flexbridge is developing an agentic version of fbAssistant with an editor. And this tool will take these inputs, will generate the software artifacts, and will let the user make some quick corrections of these software artifacts before they will be deployed and executed in like physical machines. So currently, FB editor that is like a foundational platform for integrating all functionality of fbAssistant is implemented as a plugin to Microsoft VS Code, and it is capable of working simultaneously on the same code repository as EcoStruxure Automation Expert. It can be executed in a web browser, or it can be executed in a standalone version as a plugin to VS Code in the desktop version of VS Code. So it's work in progress. It's already quite functional and supports most of IEC 61499 artifacts. And we are working on extending its functionality so that you can see inside this tool exactly the same project as it is opened in EcoStruxure tool. Okay, and now I want to go to a kind of live demo and ask our Universal Automation support to run the video. And this video will present the tool in action, and I will try to narrate it, how we envisage using this tool chain. So the first step is you just create an empty project in EcoStructure Automation Expert, and you import a Flexbridge skills library that is needed to help fbAssistant create software artifacts, so it includes certain templates. Then we open the same solution in fbAssistant, the same which we just created in EcoStructure Automation Expert. We simultaneously open it in fbAssistant. We can see it here, and then we start the process with importing original design documents, such as, for example, this original documentation from Festo that describes desired behavior of this station, and maybe it's like mechatronic organization. So these are PDF files that are coming from a vendor of equipment, and this includes ideas of the vendor about the functionality of this equipment. So we just take all these bunch of original documents and import to our tool with intention to extract the knowledge from these documents. So we uploaded 5 PDF documents from original Festo documentation, as you can see. And the first step for what we want to extract is IO list of signals which this entire distributing station would have. And this feature is implemented using backend LLM. And here is a result. So from the documents, fbAssistant has created a list of inputs and output signals and the types and verbal description of each signal. What is it? What is the semantics of this signal? So now we ask it to divide it into separate lists for 2 mechatronic objects. We have like the magazine and the changer, we call it, this pick and place device. And now we create separate lists. And from these, we start creating IEC 61499 artifacts. If you know IEC 61499, it has this foundational artifact called adapter interface. So we read the IO lists, and for each of these mechatronic objects, we create adapter interfaces, which immediately visible in EcoStructure Automation Expert. And you can see that now we have an EcoStructure one adapter interface for the magazine mechatronic component, and then we will create another one for the changer mechatronic component that is a pick and place manipulator. So this is a starting point of the development. We have adapter interfaces, which later will be used by more complex function blocks and will be used as a basis of connection between function blocks, between the skills in our application. Now we can create mock-up function blocks which will hold the logic of the autonomous behavior of each skill, this custom operational logic. And this step requires, it's based already on knowing the adapters. And now these blocks are generated. These are basic function blocks. And they have almost empty state machines. So these are just dummy state machines, which later will be refined into more like fully functional state machines. And then on top of this logic, we create the wrappers, the function blocks representing entire skills infrastructure. That includes the standard state machine of the skill, that is defined in the skills OPC-UA standard, and also include other servicing functions, including HMI, so that the skill can be accessed through the faceplate. So then, yes, here you see we, in one click, auto-generated the skills function blocks, in which inside we have this the logic we just created in a step before with an empty state machine. And now we need to automatically compose the skills together into the complete application. So we prefer first going this way, and then later we will be refining the operational logic of each skill. So we add the configuration information, and as a result, we create the application. And this application will be then passed to EcoStruxure Automation Expert. But then we discovered one interesting effect, that once we want to integrate the application, for example, with a simulation model that is a standard in this pre-furnished before our development, they may refer to different names of data. So we need to do matchmaking between the data. And for that, we also use the power of LLM, that using which we can create a converter between like naming of signals that we use in fbAssistant and naming of signals that were used by the developer of simulation model of this object. So we auto-generated function blocks which convert adapters developed on the side of fbAssistant with adapters used by the developer of a simulation model. You see, we insert them in between so that the data can flow freely, despite the different naming conventions used on by different developers. And then we just insert another such converter, and technically after that, our application is ready. It's fully automatically generated, but then we need to go and implement the core logic inside each skill function block. And again, we first ask LLM to provide a kind of brief description of the desired behavior extracted from original design documents. And we give the user a chance to make corrections to that, to check and correct these texts before they will be passed to fbAssistant and will be used to generate a state machine of each mechatronic component behavior. Now we pass it and we ask to generate the skill function state, finite state machine. So the state machine is generated, and again, you see that it's quite complicated state machine. And we provide the user with capability to first browse through that, understand its operation, and if some glitches or some results of LLM hallucination spotted, to correct them, which we can do by just typing in natural language certain desired corrections. Or as you can see, we can later do also by using FB editor. Here we request, for example, to remove all loopback arcs across our state machine. And it's done. Loopback arcs are eliminated. And after we happy about the way state machine looks like, we can generate basic function block that is equivalent to this state machine, and then go to EcoStruxure and see that basic function block here. So it's just a result of automatic generation. So we can little bit adjust layout, geometry, to make it more readable in IEC 61499 notation. So you see it's slightly different from our state machine notation, even though it's almost like one by one. Just in fbAssistant, the states are expanded, and you can see what is inside of the actions and algorithms in each state. So this editing can be done here. But also we can do editing in FB editor that is a part of fbAssistant. You see that Flexbridge FB editor can represent all artifacts like composite function blocks, for example. And we can also go to state machine, and we can edit it. We can make quick corrections after examining visually the state machine. We can change the events to be emitted in each state, or change the actions, change algorithms, and so on and so forth. Besides, also on the IEC 61499 side, we can use AI services. We can use LLM for analyzing, for example, our ECC in the basic function block by asking questions in natural language, like this one, trying to understand if outgoing transitions are complete, in the sense that they cover all possible combinations of logic values. And LLM makes analysis and gives us report on that. So it operates directly with 61499 code in the editor. And also we can ask if the transitions are mutually exclusive. So basically any type of requests can be applied to your project opened in FB editor. And finally, using EcoStructure Automation Expert, we can just deploy this auto-generated application to make sure it is running properly and the auto-generated state machine logic works. So it is connected with a simulation model that is also implemented within function block. And the skills are represented through the faceplates. So by invoking skills of each mechatronic component, we can see that it's working as expected and moving work pieces from one mechatronic device to another and further down to subsequent machines if there were such machines. Okay, so that was a live demo of our current state of our development, and we keep working on optimizing this agentic flow. Maybe Beata, you can stop the video and let me just show next slide, the last slide. Thank you. So as you can see here in this left corner of fbAssistant tool, we have agentic flow that starts with creation of IO list and ends with mapping application to resources. So basically with one button press, we can just invoke the entire agentic flow and sit and wait until the tool will result in a fully auto-generated 61499 project that can be tested or edited using FB editor and EcoStructure, and then executed and commissioned. So that's our kind of current state of development and intention to achieve these for more and more realistic and large automation systems. Thank you very much for your very kind attention, and our team will be happy to answer your questions, if any.
Thank you, Valeriy. Thank you for this great introduction about all the tools that you have done, and you have done a great job, all of you, to do that. Yes, that was the third part that we were introducing this AI into IEC 6.99. I'm watching the question. There was one from Jean-Yves, but I think it got answered. It was the question was if the skills are coming from Anthropics, and actually you answered with saying that you use the VDMA.
So
VDMA.
These are more automation legacy skills.
Yeah.
Yes.
Yeah. And but still, we have a few questions I see from Augustine. Which LLM is used by FB Editor, and does it require an additional subscription?
Currently, we use LLM from OpenAI. So that's based on ChatGPT, but we've been also experimenting with DeepSeek, as you can see in our fbAssistant tool. We have a switch between different models, and the same applies to FB Editor. Yes, obviously, it may require additional subscription, but also we experiment with own like LLM running on our server that is based on OpenAI 120B model, and that one we will be. I think it's quite capable, and for most of the tasks, it's quite capable, and that could be provided without subscription, I guess, or with minor subscription costs.
Great, that's good. Good. The next question. Let me show it. Is everything in the agentic flow done by
yes,
LLM?
No, not everything. Not everything. I would say that's why it is agentic. It uses some scripts and some kind of some parts of the flow are based on not on the fixed script, but on kind of flexible script that reacts on the results of LLM. So it's sort of 50-50, I would say. Some key parts are like implemented by passing the task to LLM, then the result is received, analyzed, cleaned, and decided what to do with that, and the next step is determined. But it's like, I think, normal for agentic flows.
Great. Okay. So I don't see any other question from the team that would like to share with the audience.
Yeah, maybe Dmitrii can make some extra comments.
Yeah.
I mean, coming back to the
last word.
Yeah, do you hear me?
Yes.
Okay. Coming back to the question about LLM and subscriptions. Basically, we are planning to release this FB editor with agentic capabilities for some early testing, maybe a couple months from now, and well, for the early testing, there will be some let's say free plan, so you can try it for free. But if we ever release it to mass market, the AI features will be subscription based, and it's probably going to be kind of fair price compared to, let's say, other AI services and AI providers. But the thing is, and it's always like that, like if you run LLM, there is quite a lot of computation involved. That computation costs money. So in the end, the LLM running is never free. Even when you just download the free version of ChatGPT, and run some request for free, it's maybe free for you, but it's not free for OpenAI. It's basically OpenAI pays for the computation costs to get you hooked on their services. And so now we are kind of working out what kind of business model is going to work for that. But yeah, in short, there will be some early tests available for free, but then when it's fully released, it's probably going to be some subscription based. Yes, we do use an MCP layer right now, so it's possible to couple it with different agents. But once again,
I will just state again the question for the audience from Massimiliano. Do you use the MCP layer for basically for this application? And I'll let you answer, Dmitrii.
Yes, Dmitrii said we do use MCP layer. Yes.
Yeah. So we do currently use MCP layer, so it's possible to couple it with different agents through that MCP. But once again, this is kind of some early testing right now. So we are still figuring out how the entire business model for this tool would work.
Okay, so next question now. How do you handle system file patching? Are you generating wiring for function blocks through the EAE system file?
Yes, well, you see, IEC 61499 is a standard that is based on XML representation of design artifacts. So a majority of design artifacts which EcoStruxure tool operates with are XML files. And we are just generating those files. And sometimes some patches are needed to deal with proprietary solutions that were applied by developers of EcoStruxure. So basically, we are trying to achieve a fully seamless experience when artifacts we generate are immediately readable and understandable by EcoStruxure. And so far, as you saw in the video, everything works quite smooth, with exception that EcoStruxure, after any update of the code repository, it requires reloading the project. It's more limitation on EcoStruxure side. Like when it comes to Flexbridge tools, they work seamlessly. But EcoStruxure a little bit requires of delay to pick up the changes.
It automatically reloads, but yeah, it takes a bit of time
press
to
a button, reload the system configuration.
Thank you all for watching this episode. Thank you for all the viewers for the very interesting question that you ask. Let's flash the contact details of our speakers of the day. So for sure there is Valeriy from Luleå and from Aalto, Dmitrii, for those who want to talk directly to Dmitrii, and last but not least, Tatiana from LTU as well. So thank you all. Thank you for watching this episode, and see you later on the next episode of UAO Goes Live. Thank you, and see you.
Thank
Bye.
you very much, Greg, for hosting us. And thank you.
The stream.